Hello everybody and welcome back to another visual pattern challenge. Here is our pattern today. Here's step 1, here's step 2, here's step 3. Your challenge is to predict the number of squares in step 4. And if you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see what you can do. Okay, this is an interesting looking pattern. When I look at this, I see a strange looking aardvark. So I'm going to call this an aardvark. And let's see, it looks like its ears are getting longer. Oh, but so is its neck and its legs and its tail. So it looks like we start with this original figure and we've added here, 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 added to the neck and also to the ears. Let's see, does that repeat here? Yeah, it looks like that's new, that's new. Yeah, the neck is one longer, so are the legs, and so is the tail. Is that only growing by one? That was 7 there, and this is 8. Yeah, okay. So I think we've got that. So for step 4 then, I would add one here, one in the neck here, one on the tail, and one each for the legs. And so we'd have however many that is. Let's see if we can count all this. So 6 and 8 is 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And then plus the new ones, 24, 25, 26, 27, 28, 29. So it looks like we're going to have 29 blocks in step 4. Okay, well, I think I have a hunch about what type of pattern this is, but let's verify my hunch. And actually my hunch is that it's linear, but let's verify this. So I'll make the step number in one side of the chart and the number of squares in the other. And let's see, what have we got here? 6, 7, 8, 9, 10, 11 in step 1. And in step 2, we've added 6 more, so that's 17. And in step 3, we've added another 6, so that's 23. And in step 4, we're predicting 29. And then we can take the differences between each step. 17 minus 11 is 6. 23 minus 17 is 6. And 29 minus 23 is also 6. And that bears out my hunch. I thought this was linear. And when you get a constant rate of change, a constant in the differences, you know that it's a linear pattern. And we can model a linear pattern with a linear equation. So y equals mx plus b is our equation for a line. And the m, the slope, is the rate of change of the pattern. So it's going to be the 6, the difference that we found. So y equals 6x, where x stands for the step number. And then our plus b we'll figure out here. Let's take the first part of the equation, y equals 6 times, and for x I'm going to put in 1 in step 1. So if we calculated that, 6 times 1 would be 6. That would just cover the body. And then we've got 1, 2, 3, 4, 5. We've got 5 extra squares. So let's add 5 and put that in our equation. Now I think that's the equation, but let's test it with the next step. Y equals 6 times step 2 plus 5. 12 plus 5 is 17. Yeah, that's how many we got in 2. Let's try step 3. Y equals 6 times 3 plus 5. 6 times 3 is 18, plus 5 is 23. Yeah, all right, so this looks like it's working. So I'm pretty confident we've got the right equation. Y equals 6x plus 5. And now to calculate the number of squares in step 43, we'll just put in 43 for x. So y equals 6 times 43 plus 5. And let's see, 6 times 40 is 240, and 6 times 3 is 18, so that's 258 plus 5. That would be 263. So that's how many squares I think are in step 43. What do you think? Did you get 29 for step 4? Did you get this equation? Let me know. Thanks, everybody.